and welcome to introduction video of this data structure series. You might ask, what is the need of learning data structures? Data structure plays very important role in reducing time complexity of the code. A given problem might have infinite number of solutions, but you must pick the most optimized one in order to first increase the performance of your code and second to stand out from the crowd. Data structure help us to write the code which takes less time to execute for any given problem. Apart from these benefits, data structure are also very important when it comes to programming or coding rounds before the interviews. And most of the service or product based companies like Amazon, Microsoft or Google also ask data structure problems during their one-to-one interview sessions. In this series of videos, we will be taking a deeper dive into data structures like linked list and their types, and various operations that can be performed on them, trees and its traversal methods, stack and queues, and much more. So join me into this life-changing journey to start a successful career into IT industry. Congratulations for making this great choice. So let's start learning, and all the very best.
Hello and welcome to this video. In this video onward, we will be looking at data structures and algorithm. Now let us start with the data structures. Data structure is a storage that is used to store and organize data. It is a way of arranging data on a computer so that it can be accessed and updated efficiently. Now algorithm is a collection of steps to solve the problem. Now coming back to data structure, depending upon your requirement and project, it is important to choose a right data structure for the project. For example, if you require to store the data linearly, you can go with list data structure in Python. Then there are mainly two types of data structure. The first one is linear data structure and the second one is non-linear data structure. In a linear data structure, elements are arranged in a sequence one after another, and the memory is allocated at once, and then the elements are added to the memory one after another. But after passing a certain amount of element, the linear data structure may get hard to access and consume more memory. The example of linear data structure are array data structure, stack, and queue. In array data structure, the element in a memory is arranged in a continuous memory. All the elements of array are of the same type, and the type of element can be stored in the form of array is determined by the programming language. Stack data structure. In a stack data structure, elements are stored in last in first out approach. That is, the element which is stored at a last will be removed first. You can imagine the pile of book which is kept on a table where you can access the book at the top, and if you want to add the book, you can only add that book at the top. So in this way you can imagine the stack data structure. Then we have queue. In a queue, the data is added in the first and removed from the last, which means the data stored in a queue at the last will be removed first. Now we also have a linked list. In a linked list data structure, the data elements are connected through a series of nodes, and each node stores the data and address of a next element. Now let us go toward the nonlinear data structure. Unlike linear data structure, the element in nonlinear data structure are not arranged in any particular sequence. Instead, they are arranged in a hierarchical manner where the element will be connected to one or more element in a series. Nonlinear data structure are further divided into graphs and trees. So in a graph data structure, each node is called as vertex, and the vertex is connected to another vertices through edges. In a tree, as similar to graph, the tree also have a vertices and edges, but in a tree data structure, there can only be one edge between the two vertices. The most common tree which is used is binary search tree, where each node has two childs attached to it. Now let us see some differences between linear data structure and nonlinear data structure. The data items arranged in a sequential order in linear data structure, and in nonlinear data structure, the element does not have any specific order. In linear data structure, all the items are present in a single layer. In nonlinear data structure, they might be present in different layers. In linear data structure, memory utilization is not that efficient. In nonlinear data structure, memory utilization is efficient as compared to linear data structures. Now let us move toward algorithms. Algorithms are nothing but a steps to solve a problem. Now the algorithm to be good, it should have input and output which is clearly defined. Each step in an algorithm should be clear and unambiguous. Algorithm should be most effective among many different ways to solve the problem. An algorithm should not include computer code. Instead, it should be written in any language and can be implemented and should be written in any other computer language. Now, why should we learn data structures and algorithm? Every big company like Google, Facebook, Amazon, or Netflix, they ask programmers about data structures and algorithm questions in their respective interviews. So, if you want to clear these interviews, you must know data structure well. So, if you know the data structures and algorithm precisely, you can clear every interview of any big company. So, it is always important to learn data structures as a programmer because it helps us to improve our thinking and the logic to solve any problem. So data structures are very important and every programmer must learn it. I hope you have got an idea about data structures and algorithms. In the next video onward, we will be looking in depth about data structures. So thanks for watching this video and I will see you in the next one. Hello and welcome to this video. From now on, we will start with data structures and algorithm. In short, it is also called as DSA. So we will start with linked list. So linked list is a linear data structure and it stores the data as similar to array. So there are two types of linked list. The first one is singly linked list and the second one is doubly linked list. So we have two types of linked list. The first one is singly linked list and the second one is doubly linked list. So here is a representation of singly linked list. So the singly linked list will have a head and the head pointer will point to the first element of the linked list and this element combines together called as a node. So here is a representation of node. So the node will have a two blocks and in the first block of node it will stores data. So here you can see it has store 5 and the next block will store the address of next node. So here you can see the head is pointing to the first node and the first block is storing the data which is 5 and the next block is storing the address of the next node and it is represented by using an arrow and also you can see then the next node is storing 3 and the block which is attached to the 3 is storing the pointer to its next node. Now the last node will store the null value. So if we have to attach any next node to this, for example, if I want to attach this, then I will remove this node. For example, I will remove null from this and then I will point this arrow to this next node. That means now I have added a node successfully to it. Then what I have to do? I have to add some data here. Let's say I have added 44 and after that one more thing is remain. I have to add null value in the next. So this is how we can create a next node and add value to it. So this is singly linked list. So let us see doubly linked list. I will remove this first of all. Yeah. So in doubly linked list is very much similar to the single linked list, but the only difference is, as in single linked list, the next pointer is pointing to the next node. In doubly linked list, the next node will be pointing to the previous node. So we will have a two pointer. For example, so we have head, then we have the next node, and the next node will point to the previous node like this. Similarly, this node will also point to the previous node. So this is how we can represent a doubly linked list. And if I want to add this element to the last, then what I have to do? I have to first of all erase the null. I will erase the null, and then I will point this node to the next node, which is this, and also this node will be pointing to the previous node. So this is how we can add the next block. And also we have to write null over here, and also the data, let's say 88. I will move this over here. So this is how we can add data element at the last in a doubly linked list. So in a single linked list, we have all the arrows pointing to the next element. So while traversing the single linked list, I can only traverse through starting to the end. For example, if I start from the head, then I can go to 5, then I can go to 3, 8, and then 88. But I cannot reverse traverse this list. I cannot go to the previous element. But in a doubly linked list, as we are pointing to the previous element, I can traverse to the previous element, because we have the pointer which is pointing to the previous element. That is why we can traverse in a reverse manner also. This is the next arrow, and this is the previous. So by using next arrows, we can traverse in a forward direction, and by using the previous pointer, we can traverse in a reverse direction. So this is how doubly linked list can be used to traverse in both direction. For certain examples, it will save us more time, because we have a way to go to the previous element. So let us go to a PyCharm window and let us try to create a single linked list first. Let us close all the previous work. I will create a new directory for our TSA. Create a new Python file for single linked list. So single linked list has a node. I will write that down over here. It has a node. Then we have a head. So these are the two main elements of the linked list. So let us start and try building a node. So I will write a class for node, class node. Now I will initialize a node class. So dev underscore underscore init. I have to store the data. So I will write data. So in order to move to the next element, we have to write a pointer to next. So that is self dot next. So let us initialize it to none. Then we have to store data. So I will initialize data with the data we have passed while initializing the node. So as we have seen in the diagram, we have a node, and the first block has a data, and the second block has the pointer to the next node. So here we have written, we have the next, and then we have a data. So data will store the data, and next will store the address of the next node. We can also exchange their position. So data is at the first position, and the next will store the address to the next node. So let us create a single linked list. I will write a class for head. So I will name it as linked list or a single linked list, because we are creating single linked list right now. Single linked list, so it will be more easy to understand. Then I will initialize it, and single linked list will start with head. So I will write self dot head, and it is not pointing to anything, so I will write none over here. Now let us start building a single linked list. So I will initialize a node named A with values I will take the values from our list, which is 5, 3, 8, and then 88. So I will initialize A with 5, then B node 5, 3, then C with 8, then D with node 88. So we have initialized all our nodes. Then we have to use single linked list to connect them all. So let us try that. Initialize a single linked list name SLL. So SLL equals to SLL. So I have initialized our single linked list. So we have initialized our single linked list. So I will make A as our head. So I will point our head to A. So how can I do that? So SLL dot head is A. So now our head pointer is pointing to A. That is our head pointer is pointing to 5. So this is how we can represent that. Now our A, that is 5, is pointing to 3. That is 5 is pointing to 3. So I will write A dot next equals to B, because the next is pointing to the 3. So here the 3 is represented by B. So A dot next is B. So similarly B dot next is C. Also C dot next is T. So we have written all the nodes, that is 5 is pointing to 3, 3 is pointing to 8, and 8 is pointing to 88. So A dot next is pointing to B, which is 3. Then B dot next is pointing to C, which is 8, and C dot next is pointing to D, which is 88. So in this video we have created the linked list successfully. So in the next video we will see how to traverse through the linked list. So thanks for watching this video, and I will meet you in the next one. So in this video let us see how to traverse through the linked list. So we have head pointer. So we can point the temporary pointer to the head. So let us make that. I will use a text box. So I have created a temporary element, which is temp, temporary pointer, which is temp, and I will point to that head. Then after pointing to the head, I will use a while loop. And when the temporary pointer reaches to the null or none, so as in other languages like C, C++ or Java, it is called as null. So in Python, it is referenced as none. So when the temporary pointer reaches to none, I will stop our while loop. So when this reaches to none, I will break the while loop. But before that, I have to traverse through each element. So what I will do is I will use while loop. Then I can use the next property, as we know that next property will allow us to reach to the next element. So uh, I will use head dot next. Then after using that, I will reach to the first node. Then I can use I can use temp dot next, because we have temp element pointing to this element. So the temp dot next will allow me to go to the next element. Then we will go to the 8, and then we will go to the last element. And when we will find the none, that is when we will know we have reached to the last element, we will break our while loop. So this is how we will work. So let us go to our PyCharm window. Let us start building the while loop to traverse through our linked list. So we know that we have to point a temporary element to our head. So I will write temp equals to single linked list dot head. So our temp is pointing to the head element of our linked list. So I will write while loop while temp is not none. So until we don't find a none element, we will continue traversing to the linked list. That is, we will start from head, and until we are not finding the none element, we are not stopping the while loop. Now we have written the condition. That is, when we will not find any none element, we will continue traversing to the loop. So let us print the data temp.data. So while traversing to the each element, we will print the data of that node. So I to print data in a single place, I can use end, and I can use this sign. So it will represent a linked list. And to move temp to the next element, I can use temp equals to temp dot next. So after traversing through the node, I will point temp to the next element, and let us try and run this code. So we have started from 5, then 3, 8 and 88. So here also we have written the same thing. So if you are able to run this code without any error, so congratulations for building your first linked list. So in the next video, we will see doubly linked list and how to traverse through it. So thanks for watching this video, and I will see you in the next one. So welcome to this video. In this video, let us see doubly linked list. So I will create a new file. Let us name it DLL. Let us modify our single linked list and make it a doubly linked list. I will copy our single linked list and paste it over here. So I will write here DLL, which represent a doubly linked list. So in doubly linked list, we have a node and we also have a head. But in a doubly linked list, we have two pointers. One pointer is pointing to the next element and another pointer is pointing to the previous element. So let us create the previous pointer. Let us name it prev and assign it to none. So we have created a two pointers. So the first pointer will pointing to the next element and the second pointer will pointing to the previous element. Now we have created a DLL class. So in DLL class we will have a head. So let us keep this node this way only, and instead of creating a single linked list, we will create a doubly linked list. So we have initialized our doubly linked list. So DLL and also DLL. So head is pointing to A, then A is pointing to B, but B should be also pointing to A, as we have seen in our diagram. 5 is pointing to 3, but 3 is also pointing to the 5. So let us perform that operation. So B dot previous is pointing to A. So A is pointing to B and B is pointing to A. So similarly, B is pointing to C. So C will be pointing to B. So C dot previous is pointing to B, and C is pointing to D. So D should be also pointing to C. So D dot previous it is pointing to C. So we have four nodes. So first node is A. So A is pointing to B and B is pointing to A. The second node is pointing to the third node and third node is pointing to the second node, and the third node is pointing to the fourth node and the fourth node is pointing to the third node. So this is how we can build a doubly linked list. So it is very simple if once you understand the single linked list. So our temporary element is pointing to the doubly linked list head. So this while loop will work the same. So as we are moving our temporary variable from head to the first node, then to the second node, then to the third node, and when we are finding that there is a none element, then we are stopping it. So let us run the code. So we will be getting the same output. Here I will make a small change. If temp.next is none, then I will print none is none and run the code. So you can see we have made the changes. So 88 will be pointing to the none, as we have seen here, 88 none. So as we have seen while discussing the doubly linked list, we can also traverse in a reverse manner. So we know that our last element is D. So I will initialize one another temporary pointer, which will be temp last, and I will point this to our D. So we have the last element. Then I will write a while loop to traverse in a reverse manner. So while temp last is not none. So while it is not reaching to the head element, I will keep traversing. So I'm traversing until the temp last does not reaches to the head. So let us print the data of last element, which is temp last dot data, and let us traverse to the previous element, which is temp last equals to temp last dot previous. So we are traversing in a reverse manner. So let us print all the variables, all the data in single line. So I will use end equals to, and as we are traversing in a reverse order, I will use reverse arrow. I will copy the if statement from above code and let us paste this here. So we are traversing in the reverse order, so I will change it to previous, and we will reach head at the last, so I will change it to head. So let us try and run the code. So we got an error. Let us make it temp last and let us run the code. So I'm getting the list in a reverse manner. So this is how we can traverse doubly linked list in both the manners, that is from starting to end or from ending to the start. So I hope you have understood doubly linked list and singly linked list and how to traverse through each one of them. So thanks for watching this video and I will see you. Now in this video, let us see how to add an element at the beginning of linked list. So let us consider that we have an empty node. So here we will add any data that we want. Let us say if I want to add 100 as a first node. Now I have successfully created a node. Now I have to join this element to the first node of our linked list. So let us do that. So I have joined our node to the first element. Now I want to point the head to our new node. So let us get an arrow and point our head. So now our head is pointing to a new node and our new node is pointing to the next element. So we have successfully added this element in between the head and the next node. So this is now considered as the new node at the beginning. So let us try and code this thing. So let us try and create a new function to add the element at the beginning of list. So I will write define. Let us copy it and paste and add element at beginning. So I will write peg. Let us take a single linked list as our first input and new element. So let us create a node first as we have discussed before. So n is our new node with the value of new element. Now we know that the node should be pointing to the next element of the head. So n dot next equals to head. We have passed single linked list over here, so I will write ssl dot head. Now our head should be pointing to our new element as we have seen in the figure. So head should be pointing to the new element. So I will write sll dot head equals to n. Now we have created a function to add the element at the beginning. So let us try and run this function. So I have written the name of function. I am passing the name of our linked list, which is SLL, and passing a new element. So let us try and run this code. So you can see we have successfully added 100 at the first of our element. So I'm passing here our list. I'm accepting it in our function and passing a new element. Then we are creating a new node. Then our new node is pointing to the head and the head is pointing to the node. As we can see, our new node is passing to the new element, the next element, and head is passing to this node. So the same thing we have implemented here, and let us try and add another node at the beginning, let's say 101, and let's run the code. So 101 is now added at the beginning before the 100. So this is how we can add new node. Now let us implement the same function in doubly linked list. So I will copy the same function. So let us paste that here. So I will accept here a doubly linked list. As we know that we also have a previous pointer. So the previous pointer should be pointing to the new element. So tll dot head dot previous should be pointing to the new. Then new should be pointing to the head, and similarly head should be pointing to the new element. Now let us try and add an element at the start, element at beginning. Let us pass our linked list and let us add 100 and print the linked list and let us run the code. So we have added 100 to our doubly linked list. So this is how we can add an element at the beginning of doubly linked list and also in the singly linked list. So thanks for watching this video, and I hope you have understood the concept of adding the element at the beginning and also at the last. So I will see you in the next video. Now in this video, let us see how to add an element anywhere in between the linked list. So if I want to add this element, let's say at the second position, then what I have to do is I have to first traverse to this second last element. If I want to position this element at second place, then I have to traverse the list up to the first element. Then after reaching this first element, then I have to connect the first element to the new node, and then I have to connect the new node to the next element. This is how we can add a new element between the two elements. So let us try and implement that. So def add element at location. I will take the singly linked list, then new element, then the location at which I have to add the new element. Now I will use for loop to traverse the list. So for I in range location -1, because we have to traverse one element previous to the location. So now we have reached to that location. So if now create a temporary pointer to traverse. So ssl dot head. So it is pointing to the head. So if the temp is not none, that is we are traversing, and while traversing, if it does not reaches to the end, then we will traverse to the next step. Temp is temp dot next. Or in case if we have given the value which is greater than the size of our linked list. So if I say that I have to add at 100th position, but our linked list only has 4 elements, so I cannot do that. So I have to use else condition, and I will print location is out of bound. So I am telling user that our linked list is not that long, and I will break out of loop. We have reached to the specific location using temp equals to temp dot next. Now let us add that element in between. Let us create a new node. So n equals to node of new element. Now we have to create a new pointer for next to point the next element, which is temp dot next. That is, this next element will be pointing to this node. This will be pointing to this node. Now we have created the next pointer. So temp dot next is will be pointing to n. So now this element is pointing to the new element. Now let us make the new element point to our next. So n dot next is pointing to the next, and as we know, next is pointing to temp dot next, which is this element. So this new element will be pointing to the next. So we have created a function to adding a new element at any location. So let us try and run that. So add element at location. So I will pass it a single linked list. The new element, let's say 1000, and I want to pass it at the second location. Let us print list, and I will pass our head to that list. Let us run the code. So you can see that at the second position we have passed 1000. So it will count from 0, so it will be so 0 1 2. But if you want to pass at the second position itself, counting from 1, so we can write here -2, and let us run the code again. So 1 and 2 we have passed 1000 over here. Now let us implement the same function in doubly linked list. I will copy this function. Let us paste this into a doubly linked list. So I will take here doubly linked list. We are pointing our next to the temp.next. Now temp.next is pointing to n. So n.previous should be pointing to the temp.next. As this is pointing to n should be pointing to the temp.next. So n.next is pointing to next. So next.previous should be updated with n. So this is how we have modified this function to work with a doubly linked list. So let us try and add the element anywhere in the beginning. So add element at location. I will pass doubly linked list. Then let us add 1000 at, let us say, third location. Then print the doubly linked list and run the code. So I have added 1000 at the third location, 1 2 and 3. So this is how we can add an element at in the doubly linked list as well as in the single linked list. So I hope you have understood the concept. So thanks for watching this video, and I will see you in the next one. Hello and welcome to this video. In this video, let us see how to add new element to our linked list. So let us see how to add the new element singly linked list first. Then we will see how to do it with a doubly linked list. So for a single linked list, we have to traverse from head to the last element. So here D is our last element currently, which is 88. So here, when our temporary element is reached, then we will remove the null or none from there, and we will create a new node and add new element, which is E, and then we will point D to E, and then E will point to the none. You might be little bit confused, so let us start coding this thing and you will understand. So let us do with single linked list. We will use the previous example itself. So let us create a function to add element to the linked list. So I will create a function, define add element. So I will take the head of the linked list for which I have to add the element, and I will take the new element which we have to add at the last. Let us name this as last. So add element at last. Now let's create a temporary variable which will point to the head. Now we will iterate over the temp while we until we reach to the last element. So while temp dot next is not none, we will iterate it. Temp equals to temp dot next. Now by using the while loop, we have reached to the last element. So we have reached to the D. So now our temp is at D. So we have to link E to the temp. So let us do that. So temp dot next equals to the new element, but we cannot directly assign new element to temp dot next because we have to create a node first. So let us create a node of E equals to node of new element, and let us assign E to temp dot next. Now here we have created the function. So temp is passing to the head first, then we are iterating until we reach to the last element. Then the last element will be pointing to the new element. So the new element will be added at the last. So let us try and add the new element. So add element last. So I will pass the head, which is sll dot head, and I will pass new element as 99, and let us print the list again. So to print the list I have to use the while loop, and when I run the code everything is printed in the same line. So I will print an empty space over here and run the code. So you can see the 99 has been added at the last. What we can do is we can also create a function to print the list. So let us do that. I will create a new function, define print list. I will pass head to it. Then I will paste all the code, and this temp will pointing to the head, and then we will print all the data. Let us copy the if statement from the W linked list over here. Now instead of using the while loop, I can directly write the function print list, and I can pass sll dot head. Let us run the code. So I'm getting the two linked list before adding the new element and after adding the new element. Now I hope you have understood how to add a new element to the single linked list at the last. Now let us see how to add new element to the doubly linked list. So it is very similar. Let us first create the print function first. I will just create it in a moment. I have created a function to print a doubly linked list. So let us create a function to add the element at the last. So let us copy our single linked list function and make the changes at that function. So you will be able to understand it better. What is the difference between single linked list and double linked list? So we are taking the head of a double linked list here and the new element. Now we are moving to the next, and after creating a new element node, then we are assigning last element to E. Then this E should also pointing to the previous element, which is temp. So let us do that. E dot previous equals to temp. Now we have successfully added an element to the doubly linked list. Now let us add the element. Let us pass the head dll dot head. and let us pass a new number which is 99. And when I print list and pass it the head, let us run the code. So you can see 99 has been added successfully. This is how we can write the function to add element at the last for double linked list and the single linked list. So thanks for watching this video, and if you have any doubts you can always ask me, and I will see you in the next video. Now let us see how to delete an element from our linked list. So I will write a function delete element where I will take the linked list, then the element which I have to delete. Now let us assign a temp to sll.head. So temp will point to the head. We will check if the head is our element. If temp.data is our element, if we found our element at the head position, then ssl.head equals to temp.next, which means we are now pointing our head to the next pointer. That is, if we found that our head is our element, then we are just pointing our head to temp.next. Now our head will be passing to p, and that is how we will do that if our element is found at head. Now we will make our temp none, that is tmp equals to none, and else if it is not found at head, then we have to use while loop. While temp is not none, we have to traverse through linked list. If temp.data is the element, if we found the element in between, then what will we do? We will break the loop. We will write here break. Now to store the position of the current pointer, I will create a before pointer which will be pointing to the temp, and then we have to iterate through the loop. Therefore we will write temp equals to temp.next. So this will help me to go to the next element, and the before pointer will help me to keep the track of previous element. As we have to delete that element, so we will point the before element to the next of the next element. So before dot next equals to temp dot next. So how this will happen? Uh, if I pass let's say 3, so I want to delete C. So I have pointed our BEF to B. So I will write here BEF. So BEF is B, and our temporary variable will be pointing to C. So I will write TMP over the C. Now what I am doing is I am pointing before dot next is the temp dot next, which means I am pointing before to the D. So it will create a arrow which will be like this. It will be directly pointing to the D. Let us try the different arrow. So B will be directly pointing to the D. So B is directly pointing to D, so C will be automatically discarded. So this is what we are doing in the last stage. So let us try and pass the element. I will pass our linked list. Let us say I want to delete 1000, and let us print the linked list again and run the code. So 1000 from our linked list has been deleted. So if I comment this code out and run the code, I will get 1000. And if I delete that, let us delete some more element. I will copy paste it. Let us delete the 5 and let's say 99 and run the code. So 5, 99 and 1000 has been removed from our linked list. So this is how we can implement the delete element function. Now let us try and implement the delete element function for W linked list. So delete element, I will copy this from here. Let us paste our code here. Now we are traversing through the list and I am pointing before dot next to the temp dot next. Now temp dot next dot previous should be pointing to before dot next. So just this much of modification is needed in order to make this work for W linked list. So let us try and delete an element from W linked list. So delete element, I will pass DLL. Let us make this SLL to TLL. So TLL. So here. So I will pass W linked list and the element I want to delete. Let us say I want to delete 1000 and let us run the code. Let us print the linked list again. So 1000 has been deleted. Let us try and delete some more elements. Let's say 88 and the 3 and run the code. So 88, 3 and 1000 has been removed. So this is how we can implement the delete element function for the single linked list and double linked list. So thanks for watching this video. And if you have any doubt, you can ask me. So thanks for watching and I will see you in the next one. Hello and welcome to this video. So in the previous videos, we have learned about linked list and all the major functions related to them. In this video, let us start learning about binary search trees. So binary search trees are also similar to linked list. As in a linked list, we have the next pointer. In binary search tree, we have left pointer and a right pointer, and each pointer is associated with another node, and that node also have a left pointer and a right pointer. The node which is on the top is called as root node, root. Then the node which falls below the root node is called as a child node. As this node is on the right of root node, so we called it as right child node. Similarly, as this node is on the left and it is a child of root node, so it is called as left child node. When we consider only this part of a binary search tree, this node become a root node and this becomes a left child node and this become a right child node. So as this node does not have any child associated with them, these nodes are called as leaf nodes. So these are all the main components of a binary search tree, where the first parent is called as root. Then the nodes below the root node are called as child nodes, and the nodes which are on the left side of a tree are called as a left child node, and the nodes which are on the right side of a tree are called as the right child node. When we consider a subtree in perspective, we also can call this 7 as a root node and 6 as a left child node and 8 as right child node. When the node does not have any child associated with them, then these nodes are called as leaf nodes. So as similar to our linked list, we also have pointers. As in a linked list, we have a next pointer. Here we have left pointer and a right pointer. And in between of this pointer, we have data. So whatever the data we have to store here. And in the left, we have a left pointer, and in the right, we have a right pointer. Then if this is a root node, then if I paste this here, then another node at here. And if I connect left pointer with the left node and the right pointer with the right node, then we can represent a binary search tree using these nodes. So here the data is 5, here the data is 3, here we have stored 7. So this is how we can represent a binary search tree using nodes. Now there are some points which we have to remember while creating a binary search tree. So in a binary search tree, every parent should have only two children. If we consider 5, then it has 3 and 7 as the children. If we consider 3, then it has 2 and 4 as the children. And if we consider 7, then we have 6 and 8 as the children. So this is a valid binary tree. If we add one more children to 7, then it will become an invalid binary tree. The binary tree to be valid must have only two children with respect to every parent. Now let's see another condition. So every node in a left subtree contains the less value than its parent. So every parent must have a greater value than considered to a left child. So when you consider 3, then 5 has a greater value than 3. So this satisfies our condition. When we consider 2, so 2 has lesser value than 3. So this also satisfies our condition. So when we consider 7, 6, which is lesser than 7, so this also satisfies our condition. So every parent element must have a greater value than its left child. So this is the second condition. Now let us see the third condition. So every right subtree must have a greater value than the parent, which means every right child, when we consider 5 as our parent, then the 7, which is the right child, must have a greater value. So therefore, that is 7 is greater than 5, therefore it satisfies our condition. Similarly, 8 has a greater value than 7, so it also satisfies our condition, and 3 has a greater value than 4, so it also satisfies our condition. That is, every parent element must have a lesser value than its right child, and every parent element must have a lesser value than its left child. So this is the second and third condition. Now let us see what is fourth condition. So left and right subtree each must also be a binary tree. So the right and left subtree, that is this and this, must also satisfy all the binary search tree conditions. That is, every right child must have a greater value than parent, and every left child must have a lesser value than parent. So let us create a binary search tree using the conditions we just have learned. So I will create a new file, binary search tree. So as similar to a linked list, we have a node, and instead of the next and previous pointer, we have left and right pointer. So let us create that. So we have a node. So let us create a node, class node. Let us initialize it using init method. Then we have a left pointer and right pointer. So let us create that. Self dot left. Let us initialize with none. Self dot right. Let us also initialize this with none. Now we have data to store. So let us create So let us accept a data as a parameter for data. So self.data is data. So I am storing data here. So we have created a left pointer, right pointer, and a data. So we successfully have created a class to create a node. Now let us see. Now in our binary search tree, our root child is also a node. As we have seen here, our root is also a node. So let us create a root with the node class we just have created. So our root was 5. So let us write 5 here. Then let us create another nodes of our tree, which were 3, 7, 2, 4, 6, 8. So A. Now we have created all the required nodes of our binary search tree. Now let us see our binary search tree and let us create that using our nodes. So we have a root at the top. So our root. Now our left child is 3. So root dot left is 3, which is A. Then our right is 7. Then root dot right is B. Similarly, now when we consider this subtree, then our parent becomes 3. So our left child has become 2. So A's child, so A dot left is 2, which is C, and A dot right is 4, which is D. Similarly, we have 7. So 7 is B. So B dot left. So B dot left is 6. So which is E. So we'll write E. Similarly, B dot right is 8. So F is our 8. So we will write it as F. So we successfully have constructed our binary search tree using these nodes. So I hope you have understood the basic concept about binary search tree and how to write a Python code for binary search tree. So thanks for watching this video, and in the next video we will see how to traverse through a binary search tree. So thanks for watching this video, and I will see you in the next one. So in this video, let us see what are the traversal methods in binary search tree. So we mainly have three methods of traversing in binary search tree, which are in-order traversal, pre-order traversal, and post-order traversal. In in-order traversal, we start from the left, then we go to root, then we go to right. If we consider the example with only three nodes, which is 5, 3, 7, then in-order traversal will be left, left, root, and right, which means 3, 5, and 7. Then we have pre-order traversal where we access the root first, then left and right, that is 5, then left, which is 3, and right, which is 7. In the post order, we go for left, right first, and then root, which means we go for 3, then 7, which means left and right, and then we go to root, which is 5. So these are the three main methods of traversal in BST. So if we take the whole example into the consideration, so what will be the output? So we want left first. So we will start from 5. We will search is there any left. So 3 is left. So we will search is there any left for 3. So there is 2. So for 2 we will search if there any left for 2. So there is no left remaining here. So we will print the 2, which is the leftmost element. Then we have to print the root of leftmost element, which is 3. Then we will check if there is any right for 3. So there is right for 3. Then we will check if there is any left element for 4. So there is not. Then we will write 4 here, and we will check if there is any right element. So there is no right element for 4. So we will go to root, and then we will reach at 5, because there is no more element remaining to search in this left subtree. So as we have reached to the 5, right here 5, and then we will go to right. So right, so at 7 we will check if is there any left element. So we will go to 6, and at 6 we will check if there is any left. So there is no left for the 6, so we will write 6 here. Then we will check if there is any right for 6. So there is no right, so we will go to our root, and then we will go to the right, which is 8. Then we will check if there is any left. So there is no left, then we will print 8 here, and after printing it we will check if there is any right. So there is no right, so we will stop here, and after stopping we will get our answer as here. So this is very simple to understand, and also it is very simple to code using recursive method. So let us try to implement the code using recursive method. So I will write in order. So we will be taking root as our input, which is the root of our tree. So root, I will write our sequence here. So left, then root, then right. So our base condition will be, if we find root is none, then we will return, which means there is nothing in the root, then we will stop. Then let us recursively call this function. So in order, and we want to go to the left child first, so we will write left. So root dot left, then we will print the element root dot data. As we want to print all the elements in single line, so I will write end equals to space, and I will again recursively call the function. As we want to traverse the right subtree, after traversing the left, then we will go to root, then we will go to right. So root dot right. So let us try and run this. So in order, then we will pass root of our tree, root. Let us run the code. So we get the output as 2 3 5 6 7 and 8. So let us see if it is same. So 2 3 4 5 6. Oh, I forgot to write 7 here. So we got a same output. So let us see how this code will work. So we will start with 5 as we are passing our root. Then if it is none, we will stop running the loop, because there is no chance of going forward if the root is none. But we have our root. So after checking the base condition, we will pass our root dot left in the function. So we will pass 3. So 3 will be passed, and we will check if it is none. So it is not none, so again in order function will be called with 2, as we are passing root dot left. So 3's left is 2, so it is checked, and again id check if it is none or not. So it is not, so again we will pass root dot left. So 2's left will be passed, then we will check if it is none. So it is none, so we will stop iterating over that. After this we have the print statement. So we are at 2 right now, so we will print the 2. So I will write over here. So we will print the 2, and then we will go to 3, because previous element which we have traversed, which was 3. So we will go to 3. After going to 3, we will print the data, which means we will print the 3. And after that we will go to right, which is 4. So we will print here 4. After that we will go to right, which is 4. So we will check if it is none or not. So it is not. So we will again check if it has the left element. So 4 left will be passed, so it is none, so it will be written. So we will print the data of the fourth node of this node, so it will be 4. Then we will go to the right element of 4, so we will pass that, and it will return us nothing. So it will go back over here, then it will go back to 3, then it will go back to 5. So after reaching 5, it will be at this position, so we will print 5. Then we will go to right, because after that we have right, so we will go to 7. After passing 7, then we will check if it is none or not. So it is not none, so we will check the root dot left, which is 6. So we will check if 6 has left or right. So there is no left or right for 6, so we will print 6. Then we will go back to 7. Then we are here right now, so we will print 7. Then we are checking the right, so we will go to 8. Then after passing 8, we will check if it has left, and then it does not have left, then we will print 8. And we will check if it has right, so there is no right for it, so we will stop here. So this is how we will be iterating using recursive function. I hope you have understood this code. If you have any doubts regarding this, you can ask me. So thanks for watching this video, and I will see you in the next one. So in this video, let us see remaining traversal methods. And the second one is pre-order traversal. So here we will print the root first, then we will print the left, then we will go for right. So for our example, 5 is our root. So after reaching to the 5, we will print that first. Then we will go to the left element, because we have left here. So left. So as 3 is the root, we will print the 3. Then we will go to the 2. So there is no more left. Then we will check if 2 has right or not. So there is no right, so we will print 2. Then we will print 4, because we have to go left right. So we have printed 3, then 2, then 4, root, left and right. Then we will go to right subtree. Then after going to 7, we will get our root, so we will print 7. So then we have to go to 6, left, and then we have to go to 8, which is right. So 6 and then 8. So this is how we will be traversing. So let us implement this. So define pre-order, take the root of our tree. Let us write the traversing sequence, which is root, left and right. We will first check the base condition. If root is none, then we have to return. As we have to print the root first, so after reaching to the 5, we have to print it. So I will print the root first. So print root dot data. I will write end equals to space. Then we have to go to left subtree. So pre-order root dot left. So this will help me to traverse the left subtree first. And after traversing to the left subtree, we have to go to right subtree. So I will write pre-order root dot right. So let us call this function pre-order and I will pass our root to this function. Let us run this code. Everything printed on the same line, so I will print an empty space here. Print. Let us run the code again. So we have got an output. Let us see if it matches with our output. So 532 47 and 68. So it does match with our output. Now let us see how this code works. So first we will check base condition, that is if root is none we will stop there. If it is not, then we will print the root data, as we have to print the root first. Then we will go to the right subtree, that is 3. So after getting to the 3, we will check if it is none or not. So it is not none, so we will print the data, which is 3 will be printed. Then we will again go to root dot left, so 2 will be passed. So 2, so 2 is not none, so we will print the data, that is 2. I will quickly write that here. We have gone to 5, then 3, then 2. Then there is no more element remaining, so then at the last we will go for root dot right. So root dot right will be checked if it is none or not. So it is not none, then we will go and print the 4 here. Then after that we will go for right subtree. So at the right subtree we will go to 7. Then we will check if it is none. It is not none, so we will print 7. Then we will go to 6 and check the then check its left subtree and right subtree. Then both are none, so we will print 6. Then we will go to 8. We will check whether it has a left subtree or right subtree. So it does not have both of them, so we will print 8 at the last. So this is the same thing we are getting over here. Now let us move to the post order traversal. So we will go to left, then again we will check if there is left. So there is 2, so we will print the 2. Then we will go to right, that is 4. Then we will go to root, which is 3. Then we will check we have right or not. So we do have right, so we will go to right first. Then we will check if it has left. So 7 has left, so we will go for 6. Then left has done, so we will go to right, so which is 8. Then we will go to 7, which is the root 7, and at the last we have to go to 5 and print that. So in this way we have to traverse in post order. So let us implement the code. Let us print the empty line first, and let us create a function. Define post order. Here also we will take the root. I will copy our post order sequence. So this is our post order sequence. Our base condition will be the same. So if root is none, we will return, that is we will stop executing. Then we have to print the left first. So post order root dot left, as we have to go and check all the left subtree first. Then we have to check the right subtree. So post order root dot right, and then we have to print the root. So I will write root dot data, and I will write end equals to space. So we are checking for the left, then we are going to right, and then at the last we are printing the root. So left, right, and then root. So let us call the function and pass it the root, and let us try and run this code. So we have got the solution. Let us see if it matches with our solution or not. So 2, 4, 3, 6, 8, 7, and 5. So it does match with our solution. So you must have got an idea how it works. So let us do this. So we will pass our root. So we will check if it is none. So it is not. We will pass our left child, which is 3. Then it will again pass the 2. Then there is no more left child for this, and then it will check for the right child here. So there is no right child, so we will print the data, which is 2. I will close this here. Okay, so after printing the 2, we will reach at 4. Then we will check if it has the left child or not. So there is no left child, so and there is no right child. Then we will print the data of root, which is 4. So we have printed 4 here. So we will go to 3. So 3 is our root, so we will print 3 here. And then we will go to the right subtree. After going to right subtree, we will check if it is none. So it is not none, so we will call root dot left here. So we will go to 6. Then after going to 6, we will check if it has a right. So there is no right for the 6, so we will print 6 here. So we will go to right after this. So at 8, so at 8 we will check if it has left and right. So it does not have any, so I will write 8. Then we will go back to the 7. So 7 is our root, so I will print 7 here. And after all this has ended, we will go to our root, which is 5. I will write that here. So let us see if it is same or not. So 2, 4, 3, 6, 8, 7 and 5. So this is how we have to traverse in order, then pre-order, and in a post-order manner. So I hope you have understood the recursive methods. If you have any doubts, you can always ask me. So thanks for watching this video, and I will see you in the next one. Hello and welcome to this video. In this video, let us see how to insert an element into a binary search tree. So in order to insert an element into a binary search tree, it must follow all the conditions that needed to be true for the tree to be a binary search tree. So let us read all those conditions. So the first condition is the parent should have only 2 children. Then left subtree of a node contains value lesser than the parent. Then right subtree of the node contains greater value than parent. As we can see here, the left subtree has lesser value than parent and right subtree has the greater value than parent. And left and right subtree must also be a binary search tree. So left tree must also be a binary search tree. That means it also follows the same conditions. That is, the left value should be lesser and the right value should be greater than the parent value. So let us see how to implement this. So here we have given an example to create a binary search tree. So from this number we have to build binary search tree which follows all these conditions. So here is the piece of code that we will follow while creating a binary search tree. Now let us understand this code. So the first statement is we are defining the insert function and we are taking a root and a key that we want to add. So we are taking a key that we want to add, but instead of key we have used data while creating our binary search tree. So this is one and the same. So we are taking root and the key. Then we are checking if the root is none, that is there is no tree created. So if the root is none, then we are creating the node for root and we are returning the root as the first node. Then after that, our second condition was the left subtree should contain lesser value than the parent. That means if we get the lesser value than parent, then we will insert that node to the left side of tree. That is, we are traversing to root dot left, which means the left side of the tree. And The third condition was the right subtree values should be greater than the parent, which means if this condition is not true, which means the value is greater than the parent, then we will go to the else condition and we will insert that value to the right side of the tree. So this is how this program will run. Now let us solve this example. First we have 5, so we have inserted 5, so our key is 5. Now we will check if there is a root. So there is no tree up till now, so the root is none. So what we will return? We will return a node of key. So we will create this 5 as a node and we will return this. So we have 5 here and it is a root. So by following this first if statement, we have created a root as 5. Now we will get 3 and pass this to the condition. Then we will see if root is none. So root is not none because we already have 5 as a root. So we will check if the key is lesser than root, which means 3 is lesser than root. Then this condition is true. Then we will insert this. So we will pass this key to the left side of the root. So let us create that. So I will draw an arrow to the left and here we have 3. Now we will go to 7. In 7 we will check if the key is less than root dot key. So we are now here at the root. So it is not lesser. So we will go to right and insert that. So we will go here and insert here 7. Then again we will start with 8. Then we have 8. If 8 is less than the key, it is not. We will go with the else condition, that is we have to insert it to right. So we will pass here root dot right, but there is a root dot right present. So this insert statement will again call with the same key, which is 8. Then it will go to again right of that. So it will go again to the right, and as there is no right here, so it will add 8 at this position. Now we will get 2 as a key. Now this condition is true, that is key is less than root, that is 5. Then we will go to 3 and we will again check if key is less than root, that is again true. Then we will go to again left because this condition is again true. Then after going to again left, we will see if there is any element. So there is no element, so we will add here the 2. Now we will have 4. So for the 4, so now we have 4 as the key. So if we will check this condition, if root is none, so root is not none. So then we will check if key is less than root dot key, that is key is less than 5. So the answer is yes. So we will go to 3 and we will check if the key is less than the root, which means 3. If it is less, so the 4 is not lesser than 3. So we will go to else condition and we will go to the right because here it is root dot right. So 3 dot right will be here. So there is no other element to check. So we will add 4 here. So here it should be 6 as it is already added previously. So we are at the 6. We will check if the root is none. So we have root as 5, so it is not none. Then we will go to second condition if key is less than root dot key, that is whether 6 is less than 5. So this condition is false. So we will go to right that is we are on the 7. Then again we will check if it is none, so it is not none. So we will go to second condition. If it is less than 7, so this condition is true. So when this condition is true, we go to left. So we will go here and we will check if it is none. So it is not none. Then we will add 6 over here. So we have added all the element that we have given. So let us check this with the original tree we have. So this is our original tree, and you can compare this with the tree that we have created, that we have 5 on the top, then 3 7 2 4 and then 6 8 6 8. So this tree matches with the tree that we have created. So we have got the right solution. So let us implement this code in our Python. So let us copy this. I'm at the PST file. Let us paste our insert statement over here. So instead of inserting the nodes manually, so let us try that using a function. So here we have to insert a 3. So I will write insert and I have to pass the root and I have to pass the 3. Then similarly 7, 2, 4, 6 and 8 we have to add. Let us do that. So we have inserted all the nodes. Now let us say we get the same thing for the in order traversal as we previously was getting. So let us comment the remaining code out and let us try and run this code. So instead of the key, we have used data over here. So I will change key to data. So data and run the code. So we have got 2, 3, 4, 5, 6, 7 and 8. So this is the same solution as we previously was getting. So this is how you can insert the node into a binary search tree. I hope you have understood how to insert an element into a binary search tree. So thanks for watching this video and I will see you in the next one. Hello and welcome to this video. In this video, let us cover stack and queues. So let us start with the stack. So stack follows LIFO approach, which means last in and first out approach. And the insertion and deletion in the stack happens at the same end. For example, we can represent a stack using a bunch of books kept on each other. We can access only the topmost book and we can keep the book on the very top, which means insertion is happening at the very top and deletion is also happening at the very top. So this is how we can understand the stack. Now we have two operations for the stack. The one operation is to add an element into the stack, which is the push operation. So I will write that over here. So push. So in the push operation, we will pass an element which we want to add into the stack. So this element can be anything depending upon the problem. It can be either an integer, string or list or anything else. Then to remove an element from the stack, we have pop operation. When we call the pop, it will pop the topmost element from the stack. For example, if I delete this element, for example, if I call the push operation and if I want to add, let's say 100 to the stack, so I will call push 100 and this 100, so this 100 element will be added to the stack at the top. When we call pop on the stack, the topmost element, whatever it is, will be removed. So 100 will be removed. If I again call the pop method, the again the element which is on the top will be removed, and this will follow until the stack is empty. If the stack is empty and we call the pop method, we will got an error. Let us suppose if I push 101 and this is my element 101, and if I call push method on the stack, then this will add 101 to the stack. Then if I call push 100, then this element will be again added to our stack. So this is how push and pop operation on a stack works. Now let us move toward the queue. Now queue follows first in first out approach, which means insertion and deletion happens at the opposite end. Means whatever the element which we have entered at the first will be removed first. For example, if we imagine the people waiting for a movie ticket outside a movie hall, then then the first person will take the ticket and move out of the queue, and then second person then will go for the ticket on the ticket counter and get his ticket and move out of the queue. And similarly, if a new person come, he will be joining them at the last. So this is how queue works. Now there now we also have two operations for the queue. The first operation is called as enqueue. Now in enqueue operation, I can pass the element which I want to add. After calling an enqueue method, that element will be added at the last of the queue. And then we have a dequeue method. When dequeue method is called, whatever the element which is at the front of the queue which will be removed from the front of the queue. For example, if I want to enqueue, let's say person 1 to our queue, then I will call the enqueue and I will pass the person 1 to our enqueue function. I will pass the person 1 to our enqueue function. Then this enqueue function will add the person 1 at the last of our queue. And if I call the dequeue function, the person whoever is on the front, let's say person 13, will be removed from the queue. Then these other persons will be adjusted, and if I again call the dequeue, then the person on the top will be removed. If I again call the enqueue function with passing person 13, then the person 13 will be added at the last of the queue. So this is how enqueue and dequeue operation on the queue works. So let us summarize this. So we have stack and queues. So stack follows last in first out approach, and we have queues which follows first in first out approach. Now insertion and deletion at the stack happens at the same end, and insertion and deletion in queue happens at the opposite end. At the stack we have push and pop operation. Push operation will push an element at the top of stack, and pop operation will remove the element from the top of the stack. Now enqueue function in queue will add the element at the last of queue, and dequeue function will remove an element from the front of the queue. Now I hope you have understood the stack and queues. So thanks for watching this video and I will see you in the next one. Hello and welcome to this video. In this video, let us implement stack in Python using a list. So I will initialize a list named stack. So list is initialized with a square brackets. So I have initialized a list. So stack follows last in first out approach, which means element in the stack are added and removed at the same end. Then we have push and pop method in the stack. So let us write push and pop method first. So I will start with writing a push method. So push stack. So push stack method will take an element and we have to add this element at the top of the stack. So I will write append method and pass an element. So append method will append this element at the last of the stack. Now let us write at the pop method pop stack. So pop does not take anything and removes the element at the very end of the stack. So stack dot pop the element. So this is how we can write push and pop methods in a stack. So let us try and add some element into our stack. So I will write push stack and pass, let's say 1000. Let us print the stack. So we have 1000 added in our stack. So let us try and add some more elements. So we have added 1000 to 1003 elements to our stack. So you can see each element is added on top of each other. So first 1000 was added, then on the top of that 1001 was added, and then 1002 and 1000 and 1003. So let us try and remove the element using a pop method. So pop stack. So pop method should remove the element on the very top. So 1003 should be removed first. So let us try and print the stack to validate it works or not. So print the stack and run the code. So you can see the element on the top, which is 1003, is removed from the stack. So this is how we can implement a stack using a list in Python. So let us remove some more element. So again 1002 has removed. So let us try and push, let's say 999, and print the stack. So 999 has added on the top of the stack. Now I hope you have understood how to implement the stack, push and pop methods using Python list. So thanks for watching this video, and in the next video we will see how to implement queue using Python list. So thanks for watching this video and I will see you in the next one. Hello and welcome to this video. In the last video we have implemented the stack using Python list. So in this video let us start and implement the queue using Python list. So I will initialize a list using with a name queue. So queue follows first in first out approach, which means the very first element which we have entered will be removed first, and we have NQ and DQ methods to add and delete element respectively. So let us start with implementing NQ method. So define NQ method and it will take an element. So NQ will add an element at the end of the queue. So I will again use append method. So NQ, so q dot append element. So this element is added at the last of queue. Now let us define the DQ method. So define DQ. So DQ method will remove an element from the front of the queue. So DQ method will not take any argument as we have to pop the element at the front. So I will write here pop method and pass 0th index to it. So 0th element will be popped out from the list. Now let us try and enqueue some element. So I will write enqueue and pass 1000. Let us print our queue and run the code. So 1000 has been added to our queue. Let us add some more elements. So I have added 1000, 1002, 1003, 1004 elements to our queue. So DQ method should remove the element at the front. So let us use DQ function and try to print our queue again. Let us run the code. So you can see the front, the element which is on the front, which is 1000, has been removed from our queue. So let us try and run the DQ method again. Let us run the code again. You can see 1002 has been removed. Similarly, if you call enqueue again with some another number and run the code, it will be added at the end. And DQ method will remove an element from the front of the queue. So this is how you can implement enqueue and dequeue functions of the queue using Python list. Now I hope you have understood the queue and stack and how to apply them using a Python list. So thanks for watching this video and I will see you in the next one. Hello and welcome to this video. In this video, let us implement a stack using a single linked list. So I will create a new file in our DSA folder. So let us create a node class node. So let us initialize it using init method. So for a linked list, we have data and we have a next node. So let us initialize self dot next pointer as none and self dot data as data that we will be passing while creating a node. So we have created our node successfully. Now let us create a single linked list. So I will write SLL class. I will also initialize it. Now SLL class uh, will only have a head. So self dot head equals to none So we have created a node class and a single linked list class. Now as we are implementing a stack using a linked list, we will have a push and pop method. So push method will push the element on the top of the stack, and pop method will pop an element from the top of the stack. Because stack follows first in last out method, which means element which is added first will be removed at the last. Now from our single linked list, we can use certain functions to implement push and pop method in a linked list. Now to implement push and pop method of a stack using a single linked list, we can reuse the functions that we have defined in a single linked list to implement push and pop methods. For example, I can use add element at any location to implement a push method, and delete element at any location method to pop an element from the stack. So let us copy add element at any location method, and let us rename this method with push, and let us copy the delete element method, and let us rename this method with the pop. So we have all push and pop methods. So let us create a stack. So I will define a stack with some elements in it. So stack, as we are using single linked list to create a stack, I will write here SLL, that will initialize a single linked list. Then we will create a stack with the help of that. SLL. So let us have a node with 100 in it. So stack dot head equals to A. So we have A as our head. Now let us copy the print functionality of our linked list. So print. So let us try and print our list as of now. So print list, I will pass it stack head. So let us run the code. So we have got the first element of our stack. Now let us try and push the element into our stack. So as of now we have only 100 in our stack. So let us add some elements at the end of our stack. So I will use push method. I will pass our stack into it. Then the element which I want to add, let's say 101, and the location, let's say it is 1. Print the stack and run the code. So 101 has been added to our stack. Now if I want to pop an element from the stack, I will use pop method. I will pass the stack over here, and I want to remove the element from the last. So I will pass here the element. So the element at the last has been removed. So I have made some changes in our pop method, as we want to always remove the element at the last of the stack. So this while loop will help me to move at the last of the stack, and then I'm going to remove that element by using these steps. We have discussed these steps while creating a single linked list, so you can refer these steps over there by using this code. So this is how we can remove the element at the top of stack. So let us add some more elements into our stack. So let us add 102, 103, 104. So you can see now the element has been added to our stack. So let us try and pop some element from our stack. So I will pop the element and run the code again. So you can see 104 has been removed. So let us try and remove some more elements. So I have run the pop again 2 times. So two element must be removed, that is 102 and 103. So let us run the code. So this element has been removed. So this is how we can implement a stack using the singly linked list. Now in the next video, let us implement a queue using linked list in Python. So thanks for watching this video and I will see you in the next. Hello and welcome to this video. In the last video, we have implemented stack using linked list. So in this video, let us implement a queue using linked list. So let us create a class node. Let us initialize it with init method. We will be passing data to our node. So data and self.data is data. Then we have a next pointer. So self.next equals to none. Now let us create a class for single linked list, class SLL, initialize it with init method. So we have a head in our single linked list. So head, let us initialize it with none. So we have created a node and single linked list class. Now to implement queue, we have first in first out approach. So the element which is entered first should be removed at the first. So we have enqueue and dequeue method in a queue. So let us use our previous code to implement enqueue and dequeue method. So I will copy the push and pop method from a stack. Let us print that over here. So instead of push, we have enqueue. So enqueue method will always add an element at the start. So instead of using a location parameter, I will define a location which will be always 1. So we will be adding element at the start always, and the pop method removes the element from the end, so we don't have to uh, change anything over here. Now let us change the name of pop method to dequeue. So after we have done that, so let us create a queue with single linked list. Now we have created a queue. So let us create a node. I will create a default head node. So this will be our head. So q dot head equals to h. So we have created head for our queue. Now let us try and add an element to our queue. So enqueue, I will pass our queue and the new element which I want to add, let's say 100. As we have added the element, let us copy the print function of the linked list. So print list, I will call print list and let us pass head which is q dot head. Let us try and run the code. So we have head and we have added 100 to our queue. Let us try and add some more elements. Let's say 999, then 998, then 996. Let us run the code. So every element is being added at the first, as you can see over here. Let us try and add one more element. So this 100 should be added at the first position. So let us run the code again. So 100 is added at the first. So dequeue should be remove the element at the last. So let us try and run dequeue function. So let us try and run dequeue. So dequeue, and I will pass our queue to it. Let us print the queue again and run the code. So 100 at the last has been removed. So let us try and run dequeue some more times. So I have run the dequeue function 2 times. So as I have called the dequeue method 2 times, the two element which is 999 and 998 should be removed from the queue. So let us try and run the code. So this two element has been removed. So I hope you have understood how to implement queue and stack using the linked list. So thanks for watching this video, and if you feel any doubt you can use QA section. So thanks for watching this video, and I will see you in the next one.